This is Mac 1105, section 1.7, interval notation and linear inequalities. When you graphed this, x greater than 4, in high school, you most probably did it this way. You had a 4 on the number line. Because this is plain old greater, you used an open circle, and greater meant shade to the right. And what that is all of the numbers that are greater than 4, 5, 6.1, 7.9, etc., all of those numbers that are greater than 4. Well, we need to make a change right now to fit what's called interval notation, which I'll talk about in a second. You will still put the 4 here, but instead of the open circle, we use a curved parentheses. So plain old greater or plain old less will get the curved parentheses. Now this curved parenthesis, the curve, needs to face the same direction as the arrow. For less than or equal to, what you did in high school, you had the -3. Because this was less than or equal to, you used a colored in circle, and less than would be shaded out here to the left. The difference now is on -3, the less than or equal to, or the greater than or equal to, will get a square bracket. And it's facing to the left because we're going to shade to the left. This would look silly to have it facing this way and shade to the left. So the curved parenthesis and the square bracket need to face the way that your arrow is drawn. So that's one change here with the inequalities. We're no longer going to use the open circle and the closed circle. So when you have greater or plain old less, both of these will have parentheses depending on which way they're facing. If you're dealing with less than or equal to or greater than or equal to, that's when you get the square bracket. And one silly way to remember that this is the one that gets a square bracket is these little lines underneath. You could kind of think about the lines that make up your brackets. Now, let's talk about interval notation. Interval notation is a way of writing subsets or parts of the real number line, which is really what we did up here. When you graph this right here, that's a subset. That's a part of the number line. That is the number line from 4 all the way to the right. This is part of a number line. That is from -3 down to the left. So that's what interval notation is. It's just a way of writing the solution to an inequality. Of course, we will also use interval notation in other topics in this course, but right now we're using it to display the answer to an inequality. So let's look at some of these in general. When you do the interval notation for something like this, the first thing we want to do is look at the graph. Now this is a compound inequality, and what you did back in the old days with the -1 and with the 3, what this is saying right here is that the x is located between the -1 and 3, which means we need to shade between the -1 and 3. All we have to decide on is what symbols do we put here? Do we do the parenthesis or do we do the square bracket? Because both of these are plain old less than signs, we will do the curved parentheses. Now that fits exactly what this inequality says. This says the x is between -1 and 3. Where have I shaded? Between -1 and 3. Now the interval notation comes directly from your graph. It's almost as if we could just pull the line away and only have these numbers left. And these numbers, it begins at -1 and it goes through 3. Now what the curved parenthesis is saying is that -1 and 3 themselves are not part of this solution. Every number between -1 and 3 is, but not -1 and not 3. Now we have to talk about something called set builder notation. Set builder notation is just a fancy way to write this inequality. The set builder notation begins with parentheses, x, we put a bar here, a line there, and then we just rewrite the inequality. We will use set builder notation in this course every now and then. That's why I'm going over it now. How this translates is the set, that's what the squiggly is, the set of all x such that, that's what the long line is, -1 is less than x, which is also less than 3. Another one of these compound inequalities, the graph. We've got 5, we've got 7. That tells me x is between 5 and 7, so I need to shade between 5 and 7. But because this is less than or equal to, I need to put a square bracket on that. And those square brackets are facing each other like bookends, just like the parentheses were facing each other like bookends. The interval notation comes directly from these numbers. It is bracket 5, comma, 7, bracket. And what that means is we have shaded every number between 5 and 7, including 5 and including 7. Now the set builder notation is the set of all x such that 5 is less than or equal to x, which is less than or equal to 7. Close your curve. So what you should see there with the set builder notation, this is what you started with. All you added to this to make it set builder notation is this fancy squiggly x with this line, and then close off the squiggly at the end. That's all you have to do for set builder notation. There are times in this course you're going to put answers in interval notation, and sometimes you're asked to put them in set builder notation. Now the reason I started with these two compound inequalities is that the interval notation makes the best sense. Your x is located between the 5 and 7. We shaded between the 5 and 7, and our interval notation is the 5 to the 7. When we look at this, x greater than 2, here's our 2, greater than is going to go to the right, and because it's plain old greater, it gets the curved parenthesis. You know, in my mind, the one difference is back in the old days when I taught how to graph x greater than 2, we did the 2, we decided right away that this is going to be an open circle, and then we did the shading. Here I'm thinking about the shading first because the shading direction is how I decide about my parenthesis or bracket which way it's facing. Now the interval notation on this, just pretend the line isn't there. What you would have is a 2 with a parenthesis right there, comma. Where is this line going? Forever and ever and ever and ever and ever to the right? That is infinity. And infinity always gets the curved parentheses. If we want to do set builder notation, I'm going to go up to the problem here and just use it. Squiggly, x, such that x is greater than 2. That's all you have to do for set builder notation. X greater than or equal to 3. Here's my 3. Greater than is going to the right. Because it's greater than or equal to, it's a bracket facing that direction. Interval notation, you see a bracket, you see a 3, comma, it's going all the way out to the right, which is infinity. Infinity always gets a curved parentheses because infinity is not an actual number, it's a concept. And if you looked at this from the interval notation standpoint, let's say you didn't have a graph to look at, this is saying my graph begins at 3, including 3, and we're shading all the way out to the right to positive infinity. Positive infinity is way out here, negative infinity is way out here. Set builder notation, going up to the top here, squiggly, x, such that x is greater than or equal to 3. X less than 1. Here's my 1, less than, shades to the left, less is left. It is a plain old less, so I will have a curved parentheses, and I want to be sure I shade up close to that curve. Now this is where you have to be careful with the interval notation. A lot of people want to call this 1, comma, whatever. Well, you have to think about where this 1 is. This 1 is what I call a backwards parentheses. It's a backside parenthesis, so it's at the back. So it's 1 here, and then the graph is going forever and ever to the left, and forever and ever to the left is negative infinity. Negative infinity also gets the curved parentheses. Set builder notation, I'll just go up here, dress this up, and there you go. One more of these. Here's my graph. Less than or equal to 3, less than is shading out to the left. Because it's less than or equal to, we get the square bracket. Interval notation, this 3 is with the backside bracket, so the 3 is here, comma, it's going forever and ever and ever to the left, which is our negative infinity, with the curved parentheses. Set builder notation, let's go up here, just dress this up, squiggly, x such that x is less than or equal to 3. One little thing to be careful of, and that is on your set builder notation, if by some chance this had been something like y greater than 6, you must have agreement with your letters. So you'd have to say the set of all y such that y is greater than 6.